Okay, here comes the calculator part. So number 76, they're saying g of negative 1 is 0 and g of 2 is 5. So which has to be true here in order for there to be a point for which g of x is 3. So if you just plot these points that they give you, negative 1, 0, and 2, 5, let's see about here. So you have this function that goes through these 2 points. What has to be true about this function in order for the y value to be 3 at some point on that interval? Well, the only condition for this function would be to be continuous. Right? The function would have to be continuous between these 2 points in order for some point to have a y value of 3. If the function is not continuous, that's not guaranteed. So this is just choice B. That's it. It's a funny question for the first question on the calculator part. Okay, 77. The graph of the differentiable functions f and g are shown above. If the function p is defined by the product of these two, which is true about p prime? So let's find p prime, yeah? So p prime is f of x g prime. This is a straightforward product rule. And I want to know what's true about p prime at negative 2 and at 0. So let's put in negative 2 first. Let's see what we get. P prime of negative 2 is f of 2 g prime of 2, or negative 2. G of negative 2 f prime of negative 2. Okay. Let's see. From the graph of f of 2 here is 0, right? So that's 0. I don't care what that is because this whole thing is 0 then. G of negative 2 is 1, 2, 3, negative 4. F prime of negative 2 is some positive number, right? F prime is the slope at x equal to negative 2. So this is some positive number. So this is less than 0. Okay. So far, so good. Okay. I guess it's got to be A. We've lucked out. Next one is 79, and this requires a calculator. Where is that? 78. No, that's 78. I'm sorry. 78, which requires a calculator. Okay, my printer is just going nuts, so I can't. It gives me horizontal lines here. Rate at which motor oil is leaking from an automobile is modeled by that function. Blah, blah. How much oil leaks out during the first half hour? Right? So all you need to do is nothing special on the calculator. From 0 to 1/2 of 1 plus sine t squared dt. That should be it. Just make sure your calculator is in let's see, that's my mode, radian mode. Okay, so math 9. So mine is an old calculator. Yours is slightly different. Squared comma x comma 0 comma 0.5. Just make sure you put in the square where it's supposed to be. You're squaring the x, not the sign. So that's 0.541. Yeah, 0.541. So that looks like it's choice D. And that's it. Nothing special. Okay, 79. Function of f has derivatives of all orders for all real numbers. F of 0. F prime, F double prime, and F triple prime. Third degree Taylor polynomial for G. Okay, about x equal to 0. So that's basically the formula, right? Third degree. So the Taylor polynomial, third degree, is going to be f of 0 plus f prime of 0x plus f double prime of 0x squared over 2 factorial triple prime 0 x cubed over 3 factorial. This is triple, right? Just by the formula. So they gave us everything. F of 0 is 3. It's a substitution game. That f double prime is 2 divided by 2. That'll be 0. That will be 1, right? So this is just x squared. And triple is 1, so that's going to be 1 over 6 x cubed. Okay, but this is f. All right. But they want me to find one for g, and g is the antiderivative of f, right? So let's do this. So if I take the antiderivative of f, I would get g, right? So that would be 3x minus 2x squared for that one, plus x cubed over 3. I have to stop here because they want the third degree, so I don't have to do that. That would give me the fourth one. So is there a choice that matches that? Looks like choice C. Okay. Okay. So number 80. Another one that's no calculator. Okay. Graph of f prime. Value so which the absolute minimum. Okay. So the absolute, so if you make a sign analysis chart, this is f prime is 0 at 1, and it's positive between 0 and 1, and between 1 and 2 it's negative. So that means that f is increasing and then decreasing. So the absolute minimum has to occur at either 0 or 2. All right, so which one would have a lower value? So if you notice, by the time it gets to 2, remember the integral here, because we're looking for f. By the time it gets to 2, the integral will have all this negative area that you'll have to subtract. So there'll be more area from 1 to 2 than over here. So the lowest point would be at x equal to 2, which is choice E. This is a funky looking graph. I thought it was a ellipse at first, but it's not. Ellipse would have both of these squared. Okay, but anyway, this is easy for us. Yep, looks like we need a calculator. So we're using semicircles. Okay, so if I draw a semicircle here, this is the diameter of the semicircle. So this much is the radius. That much is the radius, right? So that's my function, my y. And we'll get to that in a minute. So remember, since I'm looking for the volume, I have to add up all these semicircles. And the area of a semicircle is pi r squared over 2. My r is y here. So it's going to look like this. Okay. So if I add up all of these, then I'll just get my volume, right, with the thickness of dx. So let's do this. So what is it, from -2 to 2 looks like? Yeah, I think I'd rather do it from 0 to 2 and then double it. It looks cleaner. And just to double check that this is 2 here, when y is 0, you have to figure out what x is, and x is 2 because 16 over 16 would give you 1. Okay, so this is indeed 2. I could put the pi on the outside. I could factor this 2 out. Well, let me not confuse you. So y squared over 2 dx. You'll see why I'm putting that there, because y is a function of x. You know what? Maybe we can fix it in here. What's y squared? Well, we can figure out y squared from here. Let's solve for y to the fourth equals 1 minus x to the fourth over 16, right? 1 minus this, and multiply by 81. But I want y squared, so I take square root of both sides. So y squared then will be 9 square root of 1 minus x to the 4 over 16. Okay, so that's really the area. Okay, so that's going to be, so this 2 here is for doubling it, because I'm doing 0 to 2. I'm doing this area here. Not area, really. These are semicircles, okay, that are coming out of the paper. But I'm doing only from 0 to 2 and then doubling. This pi I took out already. This 2, these 2 cancel out. So we'll get pi, and this 9 could come out. Right, so y squared is that. From 0 to 2. So where's my calculator? Okay. Okay, so 9 pi math. Wait, I'm not graphing. 9 pi. Put this in the front, because if you leave it for last, a lot of the times you forget. 1 minus x to the fourth over 16, comma, let's close that parenthesis, comma x, comma 0, comma 2, and I'm getting 49.425, which is choice B. Okay, and just to recap this a little bit, so the area that we find by semicircles, right? The area of a semicircle is pi r squared over 2. R in this case is my function. It's this part. That's the radius, the distance from the function, from this part of the function to the x-axis. So that's the y value squared. And we found the y value squared from the given equation. Y squared turned out to be this. Now the area is this whole thing. But I'm multiplying it by 2 because I'm doubling it, because I'm only evaluating from 0 to 2. So I'm doubling this, so the 2 cancels out, and I'm just left with the 9 pi on the outside and the integral. And that gave me this. Okay. 82. This is another calculator one. Calculator ones are going to take a little bit longer. Let's see if we could do this shorter. Okay. Average value. Okay, average value, remember. Oops. Integral of f dx. Okay, let's see if I could do this faster. Okay, so this is just the integral. So on this interval, so that's 1 over 6. Okay. Math 9. That's the integral of x plus 2 sine. Let's see this. Too much light. X plus 2. I should put this in. Damn it. X plus 2. I need another parenthesis here. Sine square root of x plus 2. Okay, comma x, comma, is it 0, comma 6? I think so, yeah. Yep. and I got 3.348, which is choice B. So that's just the formula. Okay, so 82 was B. Okay, 83. Okay, by definition, if the nth partial sum, the sum of a series is equal to its nth partial sum as n goes to infinity. So if this is the nth partial sum and I take the limit as n goes to infinity, I get a third. Done. Done. Gotta charge me phone. Good night.